All right, getting ready for that big Class 10 chemistry exam? Think of this as your secret weapon. We're going to cut right through all the fluff and focus only on the questions from Chapter 1 that are practically guaranteed to show up.
Yeah, I totally get it. You crack open that textbook and bam, just pages and pages of chemical reactions. You're probably thinking, which of these do I actually need to know? How on earth am I going to remember all this when the pressure's on? Look, that's a feeling every single student has. You're not alone.
But what if I told you there's a shortcut that you only need to really master a handful of them to score big? Well, that's exactly what we're going to do right now. We are laser focusing on the heavy hitters, the reactions and the little memory tricks that are almost guaranteed to be on that paper. Just stick with me and I promise you'll walk into that exam feeling ready to crush it.
Okay, let's dive right in. First things first, the master mnemonic key, which is all about the reactivity series. Seriously, this is the foundation for everything else in the chapter.
And I am not kidding around here. The source material basically says, if you don't remember this, just forget the whole chapter. It is that important. Getting this right is your ticket to locking in 2 or 3 easy, guaranteed marks. So let's make sure you know it.
So how in the world are you supposed to remember this whole list? Easy, with a fun little mnemonic. Let's break it down together. Katarina gives us K for potassium. Na is Na for sodium. Car is Ca, calcium. Manji is Mg for magnesium. Then we have a cool one, Alto Zen Ferrari, that's for aluminum, zinc, and iron. The final stretch is Fear Be a High for lead, that's Pb and hydrogen. And to wrap it up, Kiomili Silver Adi for copper, mercury, silver, and gold. Just say that out loud a couple of times, scribble it down, and boom, you've just unlocked the key to a ton of questions.
All right, so you've got the reactivity series in your back pocket. Now let's put it to work. We're moving on to some crucial thermal breakdowns. These are reactions where heat is basically the star of the show, breaking things down. It's called thermal decomposition.
Okay, a perfect example of this is heating lead nitrate. Picture this. You start with this clear, colorless crystal. You apply some heat, and suddenly things start happening. You get 3 different products. But here's what you really need to look for, the visual clues. You'll see this yellow solid forming, that's lead oxide. And you'll see these brown fumes coming off. That's nitrogen dioxide gas. Yellow solid, brown fumes. Got it? The examiners love asking about those colors.
Next up, the ferrous sulfate story. This one has a fantastic way to remember the color changes. So you start with these green crystals. First, when you heat them, they lose their water and turn white, kind of like a face going pale right before a fight. Then, as you keep heating it, it breaks down and turns this reddish-brown color, like that same face getting all red after the fight. Pretty cool, right? And what else do you get? A couple of not-so-friendly gases, SO2 and SO3, the same ones that cause acid rain.
All right, let's switch gears. Now we're looking at what happens when metals meet the air, specifically burning and oxidation. And you're going to want to pay close attention, because we're kicking this off with a major exam alert.
Okay, listen up. I cannot say this enough. Burning a magnesium ribbon, this is a 100% absolutely gonna be on the test question. I'm serious. You will see this. It could be for 1 mark, 2 marks, maybe even 3. You have to know this one cold.
So what exactly happens? You light the magnesium ribbon and it burns with this incredibly bright, white, dazzling flame. What's left behind? A white powder called magnesium oxide. Simple enough, right? But here's the trick question they always ask. Why do you have to clean the ribbon with sandpaper before you burn it? Well, it's because magnesium is pretty reactive. It naturally forms this dull, protective layer of magnesium oxide on its surface just from sitting in the air. That layer won't burn, so you use sandpaper to scrub it off, exposing the pure magnesium so it can actually react and give you that amazing flame.
You know, that protective layer on magnesium is actually a form of corrosion. So, speaking of metals reacting with their environment, let's dive into the story of corrosion. It's the general word for how metals break down, but you'll see that different metals have their own unique way of doing it.
Now here's a super important point people get wrong all the time. Not all corrosion is rusting. Rusting is the special name we give only to the corrosion of iron. You know how silver jewelry or anklets can turn black over time? That's not rust, that's tarnishing. It's silver reacting with sulfur in the air. Or how about the Statue of Liberty, that famous green color? That's corrosion too, but it's copper reacting with carbon dioxide and water. So yeah, this little table right here, it's your perfect cheat sheet for keeping them all straight.
Okay, time for a really practical one that pops up on exams all the time. The chemistry of whitewashing walls. It's a really neat 2-step process.
Step 1 is what we call slaking the lime. You take calcium oxide, which you might know as quicklime or tuna, and you add water to it. And wow, this reaction is intense. It's super vigorous and exothermic, which is just a fancy way of saying it releases a ton of heat. Like, the container will literally get hot to the touch. And what you're left with is calcium hydroxide, also called slaked lime.
But that's not the end of the story. Here's where it gets really cool. You take that slaked lime and paint it on the walls, right? But the shiny, brilliant white finish, it doesn't show up right away. Nope, there's a second step that needs to happen.
So, over the next 2 or 3 days, that calcium hydroxide you painted on the wall slowly reacts with the carbon dioxide that's just naturally in the air. This slow dance creates a thin, hard, milky layer of something new, calcium carbonate. That is what gives the wall that beautiful, shiny finish. And here's a little bonus fact you can use to impress your teacher. Calcium carbonate has the exact same chemical formula as marble. So you're basically coating your walls in a super thin layer of marble.
All right, we're on the home stretch. We've saved one of the most important concepts for last, the electrolysis of water. It sounds complicated, but all it means is we're going to use electricity to split water back into its basic parts.
So, the first big question they'll ask you is, where do the gases go? You've got 2 electrodes, a positive one and a negative one. It's actually pretty easy to remember. Oxygen gas collects at the positive anode. Hydrogen gas collects at the negative cathode. Simple as that. Just whatever you do, don't get those two mixed up. Okay, next question. How much of each gas do you get? Well, just think about the formula for water. It's H2O, right? That little 2 tells you everything. It means you're going to get 2 parts hydrogen for every 1 part oxygen. So the amount of hydrogen gas you collect will always be double the amount of oxygen. That 2-to-1 ratio is another one of those classic exam questions they love to ask.
All right, so you've done the experiment. You've got 2 test tubes filled with invisible gas. How do you actually prove which one is hydrogen and which one is oxygen? Well, there's a really simple test for each.
To test for hydrogen, you just take a lit match or a burning splint and bring it to the top of the test tube. If it's hydrogen, you'll hear a little pop sound as the flame goes out. Now for oxygen, you do something a little different. You light a splint, then blow it out so it's just glowing. Then you stick that glowing splint into the test tube. If it's oxygen, it'll burst back into flame. It's simple, it's effective, and trust me, you will be asked about these tests.
And just like that, you're done. Think about what you just mastered. The reactivity series, check. The thermal breakdowns of lead nitrate and ferrous sulfate, check. The details of burning magnesium, got it. The whole story of corrosion, you know it. The 2-step whitewashing magic, done. And finally, the electrolysis of water, mastered. You seriously now have the absolute core of this chapter down. You literally have the keys to all the most important questions from this chapter. The only thing left to do is to go use them. So my question for you is, which one are you going to go unlock first? You've totally got this. Go get them.